Hi, I'm Joe James. In this video I'm going to explain the trigonometric functions sine, cosine, and tangent. So here we have an xy coordinate system with x and y axes, and we have a unit circle, which is a circle with a radius of 1 unit. We have a radius drawn on here with a radius of 1, and we call this angle theta, is the angle between the x-axis and this radius. Now we could use that radius to create a triangle. So we know that this is the hypotenuse if it's the longest side, and then we could use a vertical bar, which is the y component or the rise of the triangle, and the adjacent side to theta could be the x component or the run. So let's take a closer look at that triangle. So we have a triangle with angle theta, we have hypotenuse, which we know is equal to the length of 1, and we have an opposite side and an adjacent side, adjacent to angle theta. Now this is a standard right triangle. We can compute sine theta as the y component of theta, which is equal to the opposite over the hypotenuse. It's just a ratio. And since the hypotenuse will always be the longest side, the opposite can at most be as long as the hypotenuse. In other words, the value of sine has to be between 0 and 1. And cosine is the ratio of the adjacent side over the hypotenuse. So it's just a simple ratio. Adjacent divided by hypotenuse, which is the x component of this angle theta. Tangent is the slope component of theta, the rise over run. It gives us an idea of the slope of this line. It's equal to the opposite over the adjacent, right? This opposite side over the adjacent side, or rise over run. That's the slope. And we could also compute it as sine over cosine, since this is the sine component and this is the cosine component. So there are a few different ways to calculate this. So those are the basic definitions of sine, cosine, and tangent. So let's look at some standard angles. 0, 30, 45, 60, and 90. These have very easy to calculate values for cosine and sine. So let me show you. If we look at an angle of 0 degrees, in other words just a line going along the x-axis, the cosine value is 1, which is the radius of this circle. And the sine value is 0, and we can see actually that the rise is 0, so that makes sense. And if we have a theta value of 90, in other words a 90-degree angle or a vertical line, then we can see that x is 0 and y is 1. So cosine is going to be 0 and sine will be 1. And as our angle gets bigger, as it approaches 90 degrees, you can see that the values of cosine go down from 1 to 0, and the value of sine goes up from 0 to 1. And in fact, it's pretty easy to calculate. Sine goes from 0 to root 1 over 2 to root 2 over 2 to root 3 over 2 for 30, 45, and 60 degree angles. And cosine does the opposite. It goes from 1 to root 3 over 2 to root 2 over 2 to root 1 over 2 to 0. Sine and cosine basically are going from 0 to 1 or 1 to 0, but that's just in the first quadrant. If you look at all 4 quadrants of this unit circle, so quadrant 2, cosine is going to have a negative value. Why? Because the x value is going to be negative. And in quadrant 3, both x and y are negative. Both the rise and the run are going to be negative values. And in quadrant 4, cosine will be positive because we're to the right of the y-axis. In other words, we have a positive value for x and a negative value for sine. In other words, if we take a look at this, as we rotate around this circle, sine starts at 0. It goes to 1 here. It goes to 0 again here. And then it's going to go to negative 1 here. And then back to 0. And cosine is going to do exactly the same thing, except that it starts at 1. It goes to 0. It goes to negative 1, and then it goes to 0, and then it goes back to 1. So as you rotate around this circle, sine and cosine are basically just alternating between 0 and 1. Because they can never be larger than 1, they can never be smaller than negative 1, because of this unit circle restriction here. So you could draw a wave of sine and cosine values. As the x-axis extends into infinity, the values of sine and cosine on the y-axis are never going to be greater than 1. They reach 1, and then they descend back across the 0 x-axis, and then they get to negative 1. And they actually look identical, these two waves, they look identical, except that they're offset by 45 degrees. Some other points here on sines and cosines. There are some laws and some identities that are really helpful and useful in solving problems. Here we have a triangle with angles, uppercase A, uppercase B, uppercase C, and sides opposite those angles of lowercase a, lowercase b, lowercase c. The sine of uppercase A over A is equal to sine B over B is equal to sine C over C. So those three ratios are all equal to each other. That's the law of sines. The law of cosines is a little more complicated. I'm not going to try and drill through and explain all of this. And then there are also the Pythagorean Theorem applies to this as well. So sine of theta squared plus cosine of theta squared is equal to 1 squared, where 1 is the radius of the triangle. So this makes sense intuitively, because this is just an application of the Pythagorean Theorem to the triangle that we created. And there are some addition identity and subtraction identity, which are a little more complex, but I'll include these in the video for completeness. That concludes my video on sine, cosine, and tangent. I hope this video was helpful for you, so please click the thumbs up and subscribe to my channel. I'm Joe James. Thanks for watching.